Hello there and welcome. In this lesson, we're going to learn about asynchronous programming. As you already know, our code runs sequentially. It means that it will go line by line and it will execute and do any kind of logic it will find. If we have a method, then it will enter into this method and do the logic inside of it and then exit the method and continue. For example, if we use our Pokédex object, and then we do Pokédex, maybe print all Pokemon, and then we do something else, then it will start with this main program, with this main method. It will run this line, it will create the object, then it will see that there is nothing on line 2, it will continue to line 3, it will continue to line 4, it will see that we are calling a method, so it will enter into a method, and you can simply hold Control and click, and it will go inside. And then inside of this method, it will start a new block of code. So it will go line by line. It will first do, maybe we have other logic here. So it will go to the first line, then the second line, and then it will find this loop. So it's going to go over this list and do all of these loops, and then when all of these loops are over, it's going to continue. Maybe we have other logic here, and then it will do this logic, and then when everything is going to be over and we're going to reach the last line of the block, then it will simply exit this method. Maybe it will return a value, right? We have some methods that actually return a value, so it will be the last thing that is going to be done. We're going to return a value, or just exit a method if it's a void method. And we're going to come back here to the next line, and then we're going to continue, and maybe we have more methods. So this is not something new. This is the way our code is working, and we already know this, right? But what if we want to do something that takes some time? For example, maybe this print all Pokemon method will send some kind of web request and get some data from the internet. We don't know how long it will take, right? Maybe we have a slow connection to the internet. Maybe something is wrong and it will take more time. We cannot know how long it will take. And even if we know how long it will take, it can still be a lot of time. It means that this method is going to block our code. It will block this flow of code. And all of this logic here is going to wait until we get all the data. So imagine this takes 2 minutes. It means that our program is going to freeze for 2 minutes until we can actually continue and do other things. This is why we need asynchronous programming. With asynchronous programming, this will run in the background, it will run by itself until it's done, and we can continue with the other code. So our program will not be stuck, right? Imagine you're using some kind of app on your phone or maybe a program. We want to be able to still use our application while some methods and some functionality is running by itself and doing its own thing. We also want to know when this is over, right? We want to know that this entire operation was completed, and then maybe we can show some kind of message to the user. So in order to do this, we can use tasks. So let's say we want to wait for this method to be over. We can simply use a task object, and this is an object that is built in C#, and we can name it whatever we want. So maybe fetch, or maybe some kind of task. And now we're basically going to store the status of this task into this object. Now, why this is not going to work? Because we need to make our method into an async task. So we need to say async, and we need to say that it returns a task. Now, if it returns a task, it's not void anymore, right? And it basically runs on its own. So when this is going to be over, then we can go back here and we can know the status. Now, if we don't want this code to be stuck, it will still execute the code, but then we can use this task and say wait. And by waiting for this task, we can be sure that this logic was over. So maybe over here, we exit the program, or maybe all of this is inside of another method. So we don't want to exit this entire method. We want to wait for this logic to be over. So we can simply say task wait, and it will do this code, but then it will reach this part and it will wait until this is over. Okay, so we can still do other things, but we can also wait for this entire logic to be over, because now this method is an async task. Now imagine we had some code here that would actually take time, because this is, although this may take some time, especially if we have a very long list, it's still rather fast. You need to think in computer terms, right? This will take a few milliseconds and it will be very, very fast, even if we have a lot of logic here. This is not why we should use async tasks. We should use async tasks when it can take seconds or even minutes to do something. So imagine we have another method here, for example, a public get Pokemon data, maybe from the internet, or maybe get Pokemon image from the internet. And we're going to get some kind of name of a Pokemon. Then we're going to have some kind of logic that is going to get this image from the internet. It will probably be a web request that will send some kind of request to an API with this name, and then it will get the image. So instead of writing all of this logic, we can just simulate this by saying task delay, and we can create some kind of artificial delay. And we use milliseconds inside, so 3000 milliseconds are 3 seconds. And this is just something we can create, but imagine we have some actual logic here to send a web request, and it can take some seconds. So now we can wait for this to be done before we exit the method. And again, to do this, we need to turn this into an async task. And in order to actually wait for this, we need to say await. And now that we wait for this, the method is not going to be over until this is done. So it can be any kind of logic. It can be a web request, it can be downloading some information, it can be even writing into a file, anything that can take some time. By saying await, we wait for this, and only when this is over, we're going to continue here with other logic and eventually exit this method. But we are not blocking anything because this entire method is an async task. And this entire thing here happens asynchronously, and these tasks happen asynchronously. We can still run code. This will still be executed while this is executing in another thread. So we don't care that we need to wait for the logic. We're not blocking anything. But when this logic is going to be over, then we can actually exit this method, and then, well, this should be this one. And then it's going to basically be saved inside of this task, and then we can also wait for it and know that the image is done. Now we also need to provide some kind of name to actually get some kind of image, because this is the parameter we specified here. But what if we want to do something with the data that we get back, right? We get some kind of image, it will probably be some kind of URL or something like that. So we want to do something with this. And for this, we can create a task that actually stores a value. For example, a string. Because this path of this image will probably be some kind of website, Pokemon API, get image, and then we basically will get the actual path for this image. So this is the response that we're going to get. And this is a string, so we want to do something with this, right? We want to do something with this information. Maybe we want to take this string path and store it into the string, and then maybe do something with it. Maybe show image using the path. Now we can, let's say, show image, and then it receives this path. We cannot do this unless we have the result. But in order to get the result, we need to make sure that the result is here. That's why we use wait. We wait until we have a result. And only when we have the result, we can get the result and set it inside, and then we can also show it. Without this, the code will be executed in the background, and maybe we still don't have the image, maybe we have a very slow internet connection, so the logic will continue running. It will be empty, right? The task will be empty because the task is still not over, so we're going to get an error. That's why we need to make sure that the data is available, so we say wait. And then we can use the result and show this path. But now, because it's a type of task that stores a string, we also need to say that this returns a string task. So we say task string. And we also need to basically return this string. So over here, maybe we're going to get this string. So we return this string. It can be some kind of string that we got, this URL. So return this URL, something. And now that we got this from the internet, it will wait for it and then it will return it, right? Because this line of code is not going to be executed until this is done. That's why we use await. If we are not using await, then it will simply skip and it will return and there will nothing to return. So with this await, we make sure that the logic for the URL is done, because this is just manual delay, but maybe we have some kind of web request method. And no, web request is not a good name because it's something built in. Maybe we have a method that does this web request and then it gets the actual string and then it will return the string, and only when this is over, then we can return the actual string. Now again, this will have its own logic and this will probably be an async task as well. So it will return some kind of task string, and then we can say that all of this will go into this response, and then we can return the response because the response is a string. But we need to wait for this to be over. Now again, we should create this method, and this method will probably be something like this. It automatically created it because it's going to return an async task, and again, it's going to do an await, and it will have some logic that will basically return this string. So to simulate this, we can simply say delay, and again, we don't know the amount of time it's going to take, but it's going to return the actual response. So when it returns this response, then it's going to be returned here, and we wait for this to be available. So only when we have this response, this will be executed, right? This will not be executed until this is done because we use await. And we can use await because it's an async task. It means that we're not blocking our main thread. We're doing this on its own thread. So only then we're going to return this response, and then over here, it's going to return this task string here. And we can also wait for this to be over, and we can get the path, the result, and show the image. So this is what you need to know about asynchronous coding, how to use async tasks. You can experiment with them, you can do your own things, you can try to have some code in the background that will do its own thing, and you can play around with this, and this is the best way to learn, because maybe something is not going to work, and then you're going to understand why it's not working. This is how we learn. So that's all for this lesson. Thank you for watching. You can subscribe if you're still not a subscriber. You can leave a like for the algorithm. You can also ask me anything you want in the comment section if something is not clear. And I'll see you next time.